Today, we're going to talk about residual stresses, and hopefully, with time permitting, we're going to talk about manufacturing with carbon fiber reinforced plastic. Last week, I have to cancel a lecture. My eyes are not well, okay? So, I've not finished marking your term test yet, but I think by tomorrow, you will know your grades. You all know your grades tomorrow or Monday? Which one? Monday? You want to enjoy the weekend or no? I'll let you enjoy the weekend, okay? Then I'll let you have your grades on Monday, okay? I don't want you to mop around. Okay, so where the last time, now, whatever I teach from now on will be tested in your final exam. Are we clear? Okay. So the topic that I've not tested you yet is on residual stresses. Okay, I've not tested you yet. So residual stress will be tested in your final exam. So where we finish off, long time ago, we look at material physical properties, okay? And we mentioned that depending on the thermal diffusivity, if the thermal diffusivity is poor, we tend to get tensile residual stress. If the thermal diffusivity is good, the higher the value means it's good, you tend to get compressive residual stress, okay? And then what's in between is 50-50. Not 50% compression, 50% tensile. The probability is either compression or tensile, okay? Now, the next thing that we're going to look at is effect of residual stresses on not effect of mechanical properties. On residual stresses. Okay. So the strain hardening component will have the most significant impact on residual stresses. Okay. So if we look at the plastic flow stress, you have A plus by B epsilon PL to the power of N. Okay, we're not going to consider the rest of the term. They have effect, but not as much as a strain hardening component. So in general, the A value, okay, will determine the possible maximum tensile or compressive residual stresses. Okay. In general, okay, your residual stresses will be usually less, okay, or the residual stress maximum. This means absolute value, either compression or tensile, is usually less than 1.1 multiplied by your A value. Okay. If it's greater than that, be very suspicious. Okay. And I'll highlight a case study or a consulting work they have done that no one have a clue what they were measuring, and they pay a lot of money to get a ridiculous value, which is wrong. Okay, and then we got it right. And the BNN, okay, will determine the depth of residual stresses generated due to mechanical loading. Okay, so the BNN. So a good way to help you study the horrible multiple choices, I'll highlight all this so when you read, you can remember. Okay, and this is also an important value, and BNN will determine the depth of residual stresses generated. Okay, this will help you in your multiple choice. You like the multiple choice? Yes or no? No, right? It's horrible, right? But you all like the long question, right? The long questions are okay. The multiple choice is a pain. So what did I tell you? You will not fail, yes or no? Focus on the what? Long question. The multiple choice, if you can do, the multiple choice is the one that for me to use who are the A student, who are the B, who are the C, who are the D. Okay, no one is an F. Are we clear? Okay, so focus on the long questions. Or not focus, have to know the long questions. Okay. Right, so by looking at this concept over here, okay, so if we have material, okay, material 1, 2, 3, and 4, and then you have your A value, and you have a B and N, okay. So the first one, the A value is high, the B and N values are high. The next one, the A value is high, and the B value is low. Okay, then you have low over here, and then you have high, and then you have low over here, and then you have low B and N. So this is just a general trend. Yeah, repeat again, this is just a general trend. So to sketch this out, if you have material based on that relationship over there, so this is our okay. So this is the depth beneath surface. Okay. And then we have our residual stresses. Okay. So if we have a value, label down here, A high, okay, and then the next one over here, this is your A low. Okay. So when you have A high, B, and N high, okay, your residual stress profile tends to look like this. Okay, so this is number 1. If your B and N, okay, I'll use a different color. If your B and N, the A is high, the B and N are low, okay, you tend to have this. So you can see with the low B and N, the residual stress can penetrate what? Deeper. Because it's softer, it's easier to what? To move. Are we clear? Okay. And then the next one, low A value, high B and N, you tend to get this sort of like profile. And then if your A is low, B and N are low, okay, you tend to have this sort of profile going on. Okay, so these are the general trend that you can usually see. Okay. Oh yeah, I label wrongly. This is number 3. And then I use the wrong color. That's why I'm colorblind, you know, cannot do electrical work. That's why I cannot become, whenever they ask me in chemistry, what is this color? Not a clue, man. Okay. Now, what is good for, what good is such profile? So what if you know such profile, right? So such profile can be used okay, to assist the temperature required okay, the temperature required for stress relief anneal. Okay, remember your stress relief anneal or the process perimeter right, required for shot pinning. Okay. So the higher the profile, okay, the higher the residual stress, right? You need to heat up to a higher temperature to stress, not necessarily a higher temperature. You can heat to a lower temperature, but you have to hold at that temperature longer time. Yes or no? And then you have to control cool again. Okay. Now, a very interesting aspect is shot pinning. Okay. So I'm going to talk a bit about shot pinning, what it actually means. Okay. So shot pinning okay, process tends to induce okay, compressive residual stresses only. Okay. It will not generate, I'm not seeing in any form that when we carry out shot pinning, you get tensile residual stress. Never happen. Okay. Yeah, never happen. Okay. So what does short pinning actually mean? Okay. So if